Right, proof number 12. We're going to just start with the givens again, okay? CD is the midpoint of, all right? CD is the midpoint of BD. So by definition, a midpoint splits a segment in half. That midpoint is splitting that segment in half. Oh man, I should read carefully. And AE. So C is the midpoint of BD, the red one, and AE, the green one. So that midpoint is accomplishing two things. Not only is it cutting that red in half, it's going to cut this green one in half. And I can't use 2 there. It's going to cut that green one in half. Okay? So I have side so far. Side so far. Right? Side. Congruent to side. Well, in the last video I said you should look for 2 things. The reflexive property, something that's shared by both triangles, which we don't have here, or vertical angles. Okay, right? Vertical angles. So I do have that, right? Oops, my bad. Right up here, I've got that green line intersects the red line, and it forms these angles here. So I've got 3 facts. I've got side, angle, side. Right? That angle is included between the 2 sides. So the postulate I'm going to use is the side angle side postulate to prove that this top triangle ABC is congruent to the bottom one, EDC. So now we're going to write it up. 1. I'll list my givens. C is the midpoint, I'm going to abbreviate, of segment BD and AE. How did I know that? Well, it was given. And 2. I don't have any more givens. Huh. Well, a consequence of this is that DC is congruent to BC. Right? And how did I know that? Well, that's the definition of midpoint. All right? And that's one pair of sides. And then the next one I saw was that AC, right? That green segment AC is congruent to EC. It's another side. And that's the same reason, the definition of midpoint. Okay? And then the last fact I had established was that this angle here, that's angle ACB. So 4. Angle ACB is congruent to angle ECD. Angle ECD. Make sure you're putting angles so they know. Okay? How did I know that? Well, I already said they're vertical angles, right? Vertical angles, and they're obviously congruent. So even in my proof, it looks like ASS or SSA. We don't go by how we write it up. We go by the diagram, right? This is a side angle side postulate, right? Side angle side. That angle is included between the 2 sides. So my last statement will be triangle ABC is congruent to triangle EDC by the side angle side postulate.